All right, now we are working on how we can use our technology, which is the Desmos calculator, in order to calculate the correlation coefficient. So go ahead and highlight correlation coefficient, which actually is the letter R on the Desmos. Between two quantitative variables, those variables are x comma y, and interpret the quantity as a measure of the strength of a linear association. Strength is whether they are weak or strong, and their association is going to be either positive, negative, or there could be no association as well. So correlation coefficient and the strength of a linear association. Let's fill in these blanks first. It says the blank can be used to show a relationship between two set of data. Association. Association can be used to show a relationship between two set of data. This could include distance and time, revenue and number of items sold, and other pairings of two variables. I mean, these are just example. If they are connected or related or associated with each other. Some scatter plots have a blank relationship. Some scatter plots have, okay, so this is association using scatter plots. You are familiar with the word scatter plots because you did them in 8th grade math. So scatter plots, when you have a bunch of points on a graph, those points could either go in a positive direction, they could either go in a negative direction, or they could be all over the place. Some scatter plots have positive relationship or positive linear relation. I'm going to use the word here, positive. Some have negative. So positive, negative, or some or others could actually have no relationship, aka zero. Either of the words, you can, it's either could be no relationship or zero relationship. The blank represented as blank measures the strength of a linear relationship. Its value is always between blank and blank. The correlation coefficient, that's what goes in the first blank. Correlation correlation coefficient, correlation coefficient. It is letter R on the Desmos calculator. When I'm going to use the calculator, same with y1 curly mx1 plus b. And it is represented as, oh, R. It measures the strength of a linear relationship. So this measures the strength, or this value of R tells me about the strength of the relationship. Its value is always between -1 and +1. So the correlation coefficient, it's the values are between -1 and +1. It cannot be more than 1, so it can't be 2, it cannot be 3, it can be 3 over 2. It is always between -1 and +1. That's all it is. All right, let's look at this image. It tells us about the range and the strength measures. So on this hand side, if you notice, R is equals to -1. -1 means it is, well, negative indicates that it is a negative correlation or negative association. And 1 means it's a perfect negative correlation, because 1 means everything was connected. Every X has a perfect relationship with every Y. There was nothing that was in doubt. So it is a perfect negative correlation. And if you look at the other extreme hand side, R is equals to +1, which means it's a positive perfect correlation or association. This is perfect. If R value is 0, it means there's no relationship. There was nothing common between X and Y. There was no association. There was no relationship. Then we are going to look on the negative hand side. So between 0 and -1, if I have values between 0 and -0.33, so one third, it is weak because it is towards the 0. So it is weak negative correlation. Again, plus and minus indicates whether it is positive or negative relationship. The number value indicates whether it was weak or strong. So one third or 0.33 is the weak, from between 0.33 to 0.66 repeating, which so one third to two third is moderate. Moderate means medium or middle values. And on if it's more than -0.66, the number, I mean, sorry, yes, the is if it's between perfect -1 and perfect -2/3, this is a strong. So more towards the 1 is strong, more towards the 0 it is weak. This goes same on the other side as well. If I am more towards the 1, it is strong. If I'm more towards the 0, it is weak. So between 0 and one third, 0.33, it is weak. From one third to two third, it is moderate, which means middle value or medium relationship. And from two thirds to +1 is kind of strong. The value of r close to -1 or +1 represents blank relationship, perfect relationship, because you already saw they are perfect. It's just perfect. While values of r closer to blank represents closer to 0, represents weak relationship. 0 means no, but closer to 0 means weak. Oh, I'm going to change the word perfect to strong. We will be using our Desmos calculator in order to find linear relationship between those x and y values, and you are going to do the same process as you would find the slope or the y-intercept from a table. First thing you do is you click on the plus sign. We're going to enter the table value. So it's a scatter plot. That's your key term. It's a scatter plot. So I'm going to enter every single value of the table into the scatter plot data into the table. So after entering my table in x1, y1, I am going to type the equation for the regression, which is y1, that curly sign, mx1 plus b. You are familiar with that equation. And now I'm going to look specifically at the r value, not just mb. No, I need to specifically look at the r value in order to find that relationship between the points. So you're already familiar with this thing. Let's interpret the correlation coefficient to determine the strength of a linear relationship. You have points over here. How do you know they're scatter plots? Because the scatter points, because these points are scattered and spread across the graph. But I can see that it is a positive linear relationship. And if I draw a line, okay, hold on. Let me draw a line and I can show you how the line is actually passing. That's how you draw the line. That the line is basically in the center of those points. If I have to determine where the line would be passing through, they're a lot closer to that line. That means it is strong. And the R value is 0.855, which is closer to 1. So this is strong positive relationship. So correlation. That's your word. It's a strong positive correlation. For the next one, if you look, the line would be actually coming down, but the points or R value is negative 0.621. This indicates it is closer to, first of all, it indicates negative. The first thing you are going to write down is it's negative, and it's closer towards 1 It's 0.66. It's kind of moderate negative correlation, so I'm going to use the word moderate. So negative and moderate correlation, because it's kind of like in the halfway. And the very last one, the R value is negative 0.018. As you can see, the points are very far apart from each other. It's practically like making a circle on the graph. So this is, first of all, it's negative, and it is very weak association because it is very much close to zero. So this is how you describe or interpret a relationship, by looking at the R value, and you can have that image saved with you so you can look back and see. If it's towards the 1, it is strong. If it's towards the 0, it is weak. If the value is positive, it is positive. If the value is negative, it is negative. So that's pretty much very clear. All right, now how can we use our calculator? You already know how to do, but I'm gonna solve first question on the calculator, and let's see, what do I get? First, click on the plus, enter the table. I am going to type in the values. This is a scatter plot, so you have to type all the values. So let me read the question. It says the table shows the durations x, so x is in minutes, of several eruptions of geyser Old Faithful, and the time y in minutes until the next eruption. Old Faithful geyser is in Yellowstone National Park, by the way. It's an amazing national park. What does the correlation coefficient for the data indicates about the strength of a linear association between the durations and the time? I have to figure out the correlation coefficient, and I have to describe what kind of correlation it is. The first thing I'm going to do is I'm going to find that R value using my calculator. So X is 2, 3.7, 4.2, 1.9, 3.1, 2.5, 4.4, and the last value is 3.9. If you notice the numbers are put in a random order, that was your second clue. It is scatter plot. So in order to get my best R value, I have to use all the numbers. Let's put in my Y value times 60, 83, 84, 58, 72, 62, 85, and the last one is 85 as well. I wine curly mx1 plus b. Okay, I have my numbers. I need R. R is 0.9787. So correlation coefficient is R equals 0.9787. It's going to be 4-digit. I'm going to use all 4 digits from there. It is, first of all, it is a positive correlation because R value is positive. Secondly, it is very, very, very close to 1. So it is a very strong relationship. So positive, strong correlation. So this is how you will figure out the correlation. I think you should be able to do the second question on your own at this time. So go ahead, pause the video and do the second question. Make sure you use the word R equals. So this way you will remember on the day of the exam that I'm looking for the R value. And also start with positive, negative, and then define whether it was strong or weak for the correlation. And you can always refer back to this image or this reference to see what kind of relationship is that. All right, so go ahead, finish that question. All right, the last part of the notes over here is that I have to make prediction. I have to make prediction using the best fit line. So your goal says right and with or without technology. So we are actually going to be using the technology, the Desmos calculator. Linear functions that provide a reasonable fit to data to estimate solutions and make predictions for real world problems. So making prediction using lines of fit. Blank can be used to estimate solution and make predictions in real world situations. Best fit line, or I have used some other terms as well, best fit lines, or is sometimes called lines of fit. That's what's written on top. Best fit line is used most of the time. Can be used to estimate solution and make prediction in the real world. Enter data into table in Desmos or TI-84 calculator. Well, we are using the Desmos calculator. You're allowed on the day of the exam as well. It's much easier to use than that TI calculator. And can generate a line of best fit by producing a slope. M is slope. You would know it by now. And B, what is B? Y-intercept. So I am going to find that line on the Desmos calculator. I'm going to identify slope y-intercept. That is going to give me an equation for that scatter plot, and I will be able to make prediction, and I will be actually using the calculator for the predictions. A problem can ask you to predict either a blank or a blank, so reading the problem in context is very important. It could either ask for x value, x variable, or y variable. So you have to pay very good attention to what exactly the question is asking you about, so you don't miss on or you don't answer wrong. So reading is a key as well over here. I will do example number 1, then I'm gonna let you do example number 2 on your own because the process is same or similar. The table shows the mileage X in thousands of miles and selling price Y in thousands of dollars of several used automobiles. Based on table, what is the best prediction of the price of an automobile with 6,000 miles? Your first clue word over there was best prediction. This means that I am going to use my Desmos calculator. So first thing I'm going to do is I'm going to refresh my Desmos calculator so I have the brand new screen. Click on plus, enter the table. X is mileage, so 22, 14, 18, 30, 8, 24. Remember, they're in thousands. 16, 17, 17, 14, 18, 15. They both are in thousand, so if you want, you can put them in thousand. If you don't want, that's fine as well. You just have to pay attention when you're gonna make the prediction. All right, I have that table values. Now I need is my equations. Y1 curly mx1 plus b. I have everything that I need over here. I don't need relationship over here, R value, so it's okay. I need the line of best fit. My line of best fit is y equal mx plus b, which is y equals, I'm going to round off those numbers. M is, okay, M is negative 83 over 452. X plus B, I'm going to find the B similar way. Um, well, you know what? I'm going to round off these values because I'm going to make a prediction. So what I'm going to do is I'm going to round off these values. I'm not writing those fractions. So y equals minus is 0.1836. So I'm going to make it 0.184. X plus b is 19.71. So 19.71. Okay, 72. Because I'm rounding it off. 6 is bigger than 1. Sorry, 6 is bigger than 5. So I have to give one place value to the 1. This is my equation of the line of best fit. Now I have to make prediction for 6,000 miles, which means I have given the value of x. I have to find the y. I have x. I need y. So there are two ways you can solve this question, to be honest. I'm going to show you both. First one, I can write that equation as function notation. So f of x equals negative 0.184 x plus 19.72. This is, I can write that as function notation. I don't need that table and equation because I copied it. And what I can do is I can put that x value, which is 6,000. But remember, I'm not writing as thousands. So I'm just going to use the value 6. And I can use the calculator like that. I can replace that x with the value of x I have. And I have it as 18.616. So I'm just going to be using my calculator. So y is the price. Price is $18.62. And this one is in thousand, so 18,000. That is how you can do this question. The second way you can do is, if you still have that equation over here, all you can do is you can say x equals 6. And you can look for where that x is intersecting with your original graph, which is in the red line this time. And then you can look for that value. And it is same value over here. If you notice, it is 18.615, which I rounded off as 18.62. So both ways you can have the answer. So I have my answers. I knew the x and I needed the y. That's the first thing you have to pay attention to. Okay, if you get that, you can use a calculator from there and you will have your answer. The second part of the question says, from the table from example 1 shows the mileage x in thousands and selling price y in thousands of dollars of several used automobiles. Based on the table, what is the best prediction of the mileage of an automobile that cost 15,500? So this time I have y and I need to find x. So this is your information after reading the question. So you have to pay attention, which one do you have? So I have the y, I need to find the x. Y is 15,000. And remember, we are not writing as thousand, so it should be 15.5. So y is 15.5. How did I figure that out? Simple. 15,500 divided by 1,000, because I was not writing as thousands. Okay, so this time what you're going to do is, in your calculator, you have that table, you have the linear regression equation. This time you have the y, so I'm going to put y equals 15.5 in the calculator. And I have a green line that I have to search for, and I have to see where it is intersecting with the red. So when y is 15.5, x is 22.946. So 22.94. So when y is when y equals 15, then x is 22.96. There you go. This is how simple it is. And if you have to make prediction, just go ahead and use your calculator. Make sure you read your question carefully, give correct information to calculator, and you will be able to find correct answer as well. You should be able to do the next question on your own. You basically have two problems to finish.